the fourth one. 1 plus sec A divided by sec A is equal to sin square A divided by 1 minus cos A. So, we'll start with LHS. 1 plus sec A divided by sec A is equal to 1 plus 1 upon cos A is the numerator and the denominator is 1 upon cos A. This is equal to 1 plus cos A divided by cos A, or LCM is cos A, therefore 1 into cos A is cos A plus 1 divided by 1 upon cos A. This is equal to 1 plus cos A divided by cos A into cos A. This is equal to 1 plus cos A. Here we prove that LHS is equal to RHS, and separately we'll simplify the given ratio. This is equal to 1 minus cos square A. Why? Sin square A plus cos square A is equal to 1. Therefore, sin square A is equal to 1 minus cos square A divided by 1 minus cos A. This is equal to 1 minus cos A into another bracket 1 plus cos A, because A square minus B square is equal to A minus B into another bracket A plus B divided by 1 minus cos A. So, this expression cancels with this expression. We are left with 1 plus cos A. Hence, LHS is equal to RHS in the simplified form. Hence, this equation is proved. Then the fifth one. Cos A, here we take LHS as cos A minus sin A plus 1 divided by cos A plus sin A minus 1. We need to prove that this is equal to cot A plus cosec A. So, continue with this given ratio. Let us divide the numerator and the denominator by sin A. So, we will get cos A upon sin A is cot A minus sin A upon sin A is 1 plus 1 upon sin A is cosec A divided by cos A upon sin A is cot A plus sin A upon sin A is 1 minus 1 upon sin A is cosec A. Here we multiply the numerator and denominator by cot A plus 1 plus cosec A. Here we use the commutative law to simplify further. We notice that cot A plus cosec A, cot A plus cosec A. We will combine those two terms, cot A plus cosec A and minus 1 this one. This expression is written as cot A plus cosec A in one bracket and minus 1 in another bracket. And this cot A plus 1 plus cosec A as cot A plus cosec A plus 1. See, we used associative law for addition and wrote accordingly. Why? Because cot A plus cosec A and cot A plus cosec A is the first term of this expression and minus 1 plus 1 is the second term of the expression in the numerator. Now, what about the denominator? We combine cot A plus 1. Right? Minus cosec A. And this one again by using the associative law for addition, we combine cot A plus 1 in one bracket and cosec A in another bracket. Here the same expression is written in two different ways. First one, cot A plus cosec A in one bracket and plus 1. In this denominator, we combined cot A and plus 1 in one bracket and then cosec A in another bracket. So that in the numerator, we have this one and this one as the first term and this one as the second term. In the denominator, cot A plus 1 as the first term of this expression and cosec A as the second term in the denominator. By using the identity A minus B into A plus B is equal to A square minus B square, we can write cot A plus cosec A bracket square, that is first term square minus the second term square. Similarly, the denominator also be written as first term square minus second term square because it is in the form first term minus second term into another bracket first term plus the second term. Therefore, the product will be first term square minus second term square as A minus B into A plus B is equal to A square minus B square. That is cot A plus 1 bracket square minus cosec square A. Using the identity cosec square A is equal to 1 plus cot square A. We rewrite this as, before that let us expand this one, cot square A plus cosec square A plus 2 cot A cosec A minus 1. By using the identity A plus B bracket square is equal to A square plus B square plus 2AB. That is first term square, second term square plus 2 into bracket first term into second term. Similarly, we can write the denominator as cot square A plus 1 plus 2 cot A minus cosec square A. That is A plus B bracket square is, that is first term plus second term bracket square is first term square plus second term square plus 2 times the first term and the second term. Here we use this identity to write cot square A as writing this cot square A as it is. In place of cosec square A, we use this identity 1 plus cot square A. This one, this cosec square A is written as 1 plus cot square A. This first term cot square A is written as it is. Second term cosec square A is written as 1 plus cot square A using this identity. Then the other terms written as it is. Minus 1. Here plus 1 and minus 1 becomes 0. We are left with, and here one more thing. This cot square A plus 1 is cosec square A. So cosec square A minus cosec square A will be 0. Therefore, we are left with 2. Okay, let us write it. This is cosec square A plus 2 cot A minus cosec square A. Did you understand this? See, first we expanded this bracket using the identity first term plus second term square as first term square plus second term square plus 2 times first term into second term and minus 1. In the denominator, the first term is expanded as first term square plus second term square plus 2 times first term into second term minus cosec square A. But we know that cosec square A is equal to 1 plus cot square A. We use that identity in the numerator as cot square A is equal plus cosec square A 1 plus cot square A. We wrote cot square A as it is. In place of cosec square A, we wrote 1 plus cot square A. Then the other terms as it is. In the denominator, cot square plus 1, cot square A plus 1 is written as cosec square A. And the other terms as it is. So in the numerator, this one and this minus 1 plus 1 minus 1 will be 0. We are left with cot square A plus cot square A. 2 cot square A plus 2 cot A cosec A divided by this cosec square A minus cosec square A will be 0. We are left with 2 cot A. Understood? If you don't understand, please call me. I'll explain it again personally. Okay? Now, the next step. When you observe the numerator, we have the common term 2 cot A in both the terms. This is first term, this is the second term. So, taking out that common term 2 cot A into bracket, we are left with cot A plus cosec A. Right? And in the denominator,